Let's do some calculus homework together. I'm going to start with number 20. Let me see. I'll open up number 20. Okay. It says if, let me zoom in. I wonder if I can zoom in more than that. It says if y equals, so this is my problem, but you may get a different looking problem, but hopefully they are similar enough. What I'm doing is going to be helpful. Okay, if y equals 1 over x to the 5th power, and, oh, they've said find, oh, this is upside down. All right, let me flip this real quick. There's all this mess. Is that better? Yes, that's better. It's not flipped anymore. They said find dy dx at x equals 2. So let's find the derivative and plug in x equals 2. So we're finding the slope of the tangent line at x equals 2. So dy dx, well, first let me rewrite this 1 over x to the 5th power, which is x to the negative 5th power. And we can use the power rule this time. Y prime or dy dx, we learned about both notation in section 1.5. It's going to be, remember the power rule, bring down that negative exponent, bring down that power of negative 5 as a coefficient. And we need to go down 1 from the original power. So the old exponent is going to, the new exponent is going to be negative 6. All right, we found dy dx. And if you want to write it again as a fraction, negative 5 over x to the positive 6 power. Now let's plug in x equals 2. Negative 5 over 2 to the 6th power. That's negative 5 over, I don't know, is that 64? Let me see. I'm typing this into my calculator. What is 2 raised to the 6th power? 2 raised to the 6th power is 64. So the answer is negative 5 over 64. Okay. I'm going to go ahead and type this in here. Negative 5 over 64. I'll move my iPad to see if I got this right. Zoom back out. And check answer. Hooray! You know, I'll keep on going because I got an email from a student in our class saying that homework problems are different from what we went over in class. So I want to make sure that I cover everything for you. All right, it says find an equation for the line that is tangent to the curve at y equals 2x to the 3rd power minus 2x at a point negative 1, 0. Notice they're asking you to find an equation of a tangent line. So guess what you need? You need the slope of that tangent line. You need your x and your y. They gave me the x and y already. X is 1 and y is 0. I just need to find the slope. In order for you to find the slope, you need to find the derivative. So let's find y prime. Let me move my little boxes on the side. I may have to make several videos, take breaks in between, but my goal is to go over 21 through 31 because I want to make sure that I teach you the stuff that I put on the homework. And sorry if I didn't go over them in class. All right, y prime is equal to, let's take the derivative. So if you bring down, or if you multiply that, 2 times 3, you'll get 6 for the coefficient, and the new exponent is 2. Minus, let's take a look at this one. If you take the derivative of 2x, that will be 2. Now, we found the derivative, y prime. We're going to now plug in what number? Plug in x value. X is equal to negative 1. And that is going to be the slope of this tangent line. 6 times negative 1 squared minus 2. That is 6 times 1 minus 2. So the slope is 4. I'm ready to do the point slope form. Y minus 0 equals, I'm going to have to take that break right after this one, 4 times x plus 1. And if I distribute the right side, I will get y equals 4x plus 4. So that is how you find the equation of the tangent line using the derivative. And we definitely focused on finding the derivative using power rule in class. So if I didn't go over enough examples finding the equation of the tangent line, I apologize. All right, let's keep going. I'm going to go ahead and check this answer. Check answer. Nice work. Okay, I'm enjoying this homework. I need to go back and record the rest of section 1.6 that I started, but I wanted to do this first so that you guys can work on your homework. There's an equation of you know what? I'll be back. I'll take a quick break and I will be right back.